Let's discuss first law of motion. Now, before moving to the first law of motion, I would like you to understand an experiment that was conducted by Galileo. By observing the motion of object on an inclined plane, Galileo deducted that objects move with a constant speed when no force acts on them. Okay. Now, see, Galileo, he has, we have this common understanding that if you suppose start pedaling a bicycle, right? So, it will move only till the point you are applying your pedaling, you are applying force. After that, it would not move. There would be a point, it would stop. But Galileo, on the contrary, he said that if you are applying a force, the body will keep on moving. If you have applied the force, it will keep on moving. It will not stop. Okay, that was his understanding. Let's see how, what is the concept that he has given us, and why do we not observe that phenomena in our daily life. Now see, the experimental apparatus used by Galileo, he used a wooden ramp with a groove cut into and a marble ball. So this is your wooden ramp, right? There was a groove, there was a path made into it and a metal ball. So what did he do in the experiment? He basically placed the ball over here, and after, since it is on the inclined plane, it moved here, and after some time it reached to the same height, right? Now, what was his observation? See, he observed that when a ball rolls down from an inclined plane, its velocity increases. The ball's velocity increases as it rolls down as unbalanced gravitational forces acting on the ball, right? See, it is going down, the speed is increasing. Similarly, when the ball climbs up, its velocity decreases as it is moving against the force of gravity. Now, Galileo argued that when the ball is released from a frictionless inclined plane, see, we need frictionless inclined plane, it will roll down the slope and go up on the opposite side to the same height from which it was released. Okay, the important point is that if this plane is frictionless, it will go back to the same height. Okay. Now, see, if the angle of inclination of right side plane are gradually decreased as shown. See, here the inclination is decreasing. First the plane was like this, then it got inclined at different angle, and in the third at this position. And after some time, we will keep on decreasing the inclination and we will make the second plane flat. Okay. The marble would travel further distance till it reaches the original height. Okay. See, here it was traveling certain distance. When the inclination was same, it again reached to the same height. But here, the inclination is decreased, but this distance, the line that we have drawn, the distance has increased, yet it is traveling to the same height. That means on this part, it is traveling extra distance. Also, if you increase the inclination again, it will again travel extra distance and it will reach to the same height. But the most important part was that, and if the right side of the plane is made horizontal, right? See, it was here, now it has been made horizontal. The slope is reduced to 0, the ball will continue to travel forever trying to reach the same height. Such an interesting example. We thought that the ball should stop somewhere, but it's Galileo, he deducted that if it is a frictionless surface, there is no friction, the ball should go on moving, it should not stop. And this gave rise to the very important law, that is the first law. So, the conclusion of Galileo's experiment was that unbalanced external force is required to change the motion of the ball. However, no net force is required to sustain the uniform motion of the ball. See, even what we commonly think is that the ball should have stopped. When we have made it horizontal, after certain distance, the ball should stop. But Galileo concluded that if the surface is frictionless, the ball will go on moving forever. It will not stop. Okay. So, we do not require force to sustain the motion, uniform motion of the ball. Now, the note, in practical situation, achieving a state of zero unbalanced force is challenging due to the presence of friction. See, that is why we are not able to observe what Galileo said, right? A common observation is the ball should stop. But why it should stop? Because friction is there. We are not able to achieve the state of zero unbalanced force, the state of zero unbalanced force. There is always a friction which is opposing. That is why we cannot see. The friction acts in the opposite direction to the motion, making it difficult for the object to maintain a constant velocity. The velocity of the object is constantly decreasing because there is unbalanced friction force. As a result, in real world scenario, the object eventually comes to stop after traveling a certain distance. Okay, that is why we cannot see the observation that Galileo made. Although his observation was perfectly correct, but this unbalanced friction force restricts the motion, decreases the velocity, and that is why the ball stops. If this is eliminated, the ball will go on forever. Okay.